Now we study what is correlation. A correlation is a statistical tool with the help of which the relationship between two variables or more than two variables is studied. It means it analyzes the change in the values of another variable if the value of first variables are changed. For example, if we study the price of a petrol and the demand for cars using the principles of economics, then we can say that the demand for petrol cars will decrease as there is an increase in the price of petrol. Such a numerical relationship between the two variables is indicated by the measure called coefficient of correlation. And this measure is indicated by R, and the value of R gives the strength of the relationship and the direction. Now let's study certain types of correlation. The first one is positive and negative. A positive correlation occurs when both variables are increasing or both variables are decreasing. For example, sales of ice cream and the temperature in the summer. We can say that the temperatures in summer is increasing. That's why the sales of ice creams are increasing. A negative correlation occurs when the value of one variable increase and the other variable decrease or vice versa. For example, as there is increase in the price of a product, the demand for the product may decrease. Another type of correlation is simple and multiple. A simple correlation is a relationship between two variables, whereas multiple correlation indicates the relationship between one variable with respect to two or more variables. For example, a relationship between the price of petrol and the sales of a car is a simple correlation, and the relationship between the yield of a crop and other variables like amount of rain, the quantity and proportion of fertilizers, the amount of seed sown, etc., is an example of multiple correlation. The third category is linear and non-linear correlation. A linear correlation occurs when the rate of change of another variable is constant with respect to the first variable. And when the ratio is not constant, then the correlation is called as the non-linear correlation. Now, in these graphs, we can say cigarette consumption and the lung cancers are simple correlation and a positive, as well as a petrol and diesel is again a simple positive and a non-linear correlation. Whereas a third graph where price and quantity is mentioned, it's an example of a negative correlation. Now let's talk about certain characteristic of the coefficient of correlation, that is R. The value of R always lies between -1 and +1. The -1 indicate that it is a negative correlation and a strong one. And +1 indicate that it is a positive correlation and a strong one. When the value of R is 0, then we can say that the two variables are not related at all. Now let's talk about how to measure this correlation. The first method is called as the scatter diagram. It is also called as a dottogram. It is a graphical representation between the two variables. It gives the output in which the two variables are plotted and the position of the points indicate the relationship between those variables. Here, the grade point average is plotted against hours spent studying. And we can see that as you spend more number of hours, your grade point increases. So this is a positive correlation between the two. Another method of calculating the value of R is Karl-Pearson coefficient of correlation. The formula is summation of x minus x bar into y minus y bar divided by root of summation of x minus x bar square and summation of y minus y bar square. By this method, we can calculate the value of R, that is coefficient of correlation. Here, x bar and y bar are the means of the data points for series x and y respectively. Now let's understand this with the help of example. Now a manager from a garment firm has an opinion that in order to increase the sales, he must invest in the marketing expenses. He has taken the sample of few firms from industry and found out the following data. Now in this particular data of sales and expenses which are mentioned in lakhs of different firms, let's assume that your sales and expenses are marked as X and Y respectively. So let's assume sales as X and expenses as Y, and then we can find out the value of R with the help of formula which is mentioned in this particular slide. Okay. For that, you need to calculate the X bar and Y bar. So for this, the X bar, that is mean for sales, is 60, and for expenses it is 4. So if you calculate the values of X minus X bar, Y minus Y bar, X minus X bar square, Y minus Y bar square, X minus X bar and into Y minus Y bar, we can have a summation of it and add these values into the formula where you can calculate the value of R, which is 0.709. This value indicates that the correlation is positive and stronger. It means any increase in the value of expenses will lead to corresponding increase in the sales. But it is interesting to note the shortcoming that coefficient of correlation cannot be considered as cause and effect. We cannot conclude that the variables are dependent and independent. For example, take a look in the table below. Here, the number of hospitals are mentioned and the corresponding sales of a garment in the same area is mentioned. If you actually calculate the value of R from this data set, you can get the value of R, that is 0.756, which means a positive and a strong relationship. But if you carefully study the data, there is no logical relation between the hospitals and the garment sales. Hence, the correlation should not be considered as a predictor of future value. That's about the correlation as of now. For more details, go for another video. Thank you.